Reality check. What major technological challenges still need to be addressed to realize full potential? And our panelists are Cynthia Breazeal on my far left, John Leonard to her right, Danielle Theobald, okay, and Antonio, then you're Antonio Torralba. So why don't we go again in alphabetical order, which gives you
so is this the clicker?
That is the clicker. It's all yours.
All right, yeah, so I actually, I just have a couple of videos that I wanted to use to kind of, I guess, tee up my opening remarks. So it's kind of a case study. And again, this is about breakthroughs, and so the point of the video is really kind of show opportunities, I think, for AI to deliver on its full potential. And when I think of that question, I really think more broadly about the democratization of AI. Can truly everyone, ages and stages, circumstance, be able to benefit from this technology? And what really needs to happen in the way we design these technologies, the performance of these technologies, the human technology systems we need to create in order to deliver on that promise. So this video that I'm going to show, it was a piece done by the New York Times highlighting a project. We've been collaborating with Boston Children's Hospital for a number of years, developing a social robot for pediatrics, for pediatric context. And this is just a clip from that. We had just finished the first clinical trial. There will be a series of these trials. This is very much a work in progress. So again, the interactions that you're going to be seeing, I'm going to use this teeing up where these opportunities I see for the future of AI. Here we go.
A patient like Beatrice, who's got a chronic condition, she's going to be in and out of the hospital. She's here for procedures. She's here for doctor's visits. She's missing school. She's missing her friends. She's really not doing any of the things that a normal kid her age is doing. And what we want to offer kids like that is just one more way of helping them to feel okay where they are in what's otherwise a really stressful experience. So I think there's a way of connecting with kids that's different from what grown-ups can offer. They have incredible imaginations, and they can really suspend disbelief, and there can be a true relationship that develops between Huggable and a patient.
Hi. Hello. Let's see. Perfect. There you go. Is that better? Hi. Oh my God. Hi. Hi, Huggable. Adorable. Okay. Yay! Let's play a game. With my little eye.
We are getting all of this physiologic data, so going forward, once that's fully integrated into the actual robot and he can respond to it, the bear may try, to engage a kid with jokes. And if those physiologic parameters aren't coming down, he'll be able to switch. Maybe this is a kid who really needs some relaxation. Maybe we'll do some guided imagery together.
All right, so again, that's just to kind of tee up, I think, a number of themes that I'd like to share with you in terms of where I see potential breakthroughs around AI. So the first of all, I think this video poses a question which I think is kind of often biased to think about, who is interacting and who is using AI. Often we assume it's people like us as professionals, but in this video, you see a range of stakeholders who can potentially interact with this social robot Huggable. You have a child who's a patient, right? You have her mother, who's in the room. You have the clinicians. You have the child life specialist, right? So who interacts with AI and how we design AI in a way that truly everyone can be able to interact with and do what they need to do in that process is a really important question and a real important opportunity, I think, for AI and how we design these systems, right? When we think about what is the nature of that interaction, we're starting to see tremendous excitement and gains in the spoken language interface, obviously. People are starting to talk to their speakers and so forth. But of course, when you see something like the Huggable, you're seeing this taken to many additional layers to think about the paralinguistics of communication, gaze, gesture, right? Expressiveness. We all know that in human communication, much of it is actually paralinguistic. And it goes beyond just understanding the content and semantics of what's being said. It's also critical forming a sense of alliance and teamwork and trust And do you like me and do I like you? So, which is really critical, again, for how we collaborate, right? All of these things are communicated through the nonverbal channels as well. When we think about the style of interaction, we often have this kind of assumption that it's like me and it's my device, or I have my screen, you know, face in the screen, I'm interacting with this intelligent computer. Very different here, right? We see a group interaction. We see, you know, a collaborative interaction, not so much me operating a tool. The nurses will talk about Huggable as being a tool, but a very different kind of tool, right? Think about the human-robot team, the differences of roles. Each player has a role to play, whether it's the child or the parent or the clinician or the nurse or the robot. And nurses are co-designing, the clinicians are co-designing this project with us because they see this as an enabler, right? In this case, the child life specialist is delivering her expertise, her service in the service of the child and the parent, in the case with the context of the Huggable. But she also sees the opportunity of, I cannot be with every child all the time, but I want to know how each child is doing so I can prioritize my time. The hospital is very keenly interested in, we can give world-class care to patients when they're in the hospital, but now we're accountable for that care when they go home. And I can't reach them. So they see something like this kind of technology as a way of engaging patients, engaging families, information, education, adherence, all that kind of stuff, apart from the hospital, right? So a lot of opportunities there. You heard Dr. Logan talk about the nature of the relationship being very different from what adults or human-human relationships are. And I think this is also a really important part. We often kind of think about human-like as being human identical or plug compatible, but there is tremendous opportunity to think about AIs that actually relate to us in a different way that actually has a lot of value. Interestingly, with these social robots, people often see them as being non-judgmental. And because of that, you can feel vulnerable, and it's okay. There's learning opportunities, there's growth opportunities in that. I think there's a tremendous opportunity and a lot of work that needs to be done in thinking about long-term interaction with these technologies. Think about children today. They're not only digital natives, they're starting to be AI natives. They are growing up in a time where they will have always been able to talk to intelligent machines. This is very new. We know very little about this and the long-term consequence of that. So thinking about this relationship, this long-term interaction, how do you design machines that can learn and grow and change with us in ways that we want to learn and grow and change with them, correct? So a lot of opportunities there. And when we think about what is the value provided, we hear, again, the topic of this conference has been on work, and it's been focused around productivity and decision-making, right? This is a technology that's meant to engage around far more humanistic, emotional needs of a child. And so when I think about the future potential of AI that I want to see delivered on, it's beyond productivity, we certainly want that. It's beyond efficiency, we certainly want that. I want to think about how AIs can help promote our well-being, our quality of life, to help us become the kind of people we aspire to be. I think that's really important to think about too. So lots of opportunities. I want to show you just one more quick video. And really the point of this is just to show,
hey, Aaron.
This is a technology that's becoming very real.
Do you want to hear a fun fact?
Sure.
I have your fortune here. Someday soon you will order the extra spicy, but later wish you'd ordered the mild.
Likely.
Okay, so very different social robot for the home. This is, I have a startup, Jibo. This is a product that just went on sale last week. And again, the point for me sharing this with you is just to say, social robots is real now, right? This is a mass consumer product, costs less than an iPhone 10, and it's also a platform. So third-party developers can also create skills and services for this. And the last thought I want to give you, again, in this democratization of AI, is not just the tools, but again, we're hearing a lot about the education. So a product like Jibo able to teach children about AI, I think is really provocative and really profound. And then on top of all of that, we've heard a lot about the ethics, which is absolutely critical to think about as well. With that, I'll turn it over to you. Thank you.
Thank you. So hi, my name is John Leonard. I'm a professor here in CSAIL and MECI, and I'm also on leave at Toyota working on self-driving cars. And since we're in the reality check session, I decided to pull a few self-driving videos. Well, these are human driving videos, difficult situations driving around Boston. Sometimes I feel like I'm a robot. I spend a lot of my time commuting, thinking, how would a robot do this task? How would a robot do another task? This is one of my favorites, is trying to make a left turn across traffic. This is near my house in Newton on a very cold day, bringing some 7th graders to school a few years ago. And I'll play it, and you can see to the right, there's traffic backed up as far as the eye can see. And to the left, there are some occlusions. There's a, oops. Oh, did that not work? Okay. To the left, there should have been some occlusions. You can see from here, mailbox, tree, telephone pole. And to execute a left turn across traffic really involves a very advanced general purpose form of intelligence. To actually make this turn, I had to wave at a driver in another car who made a gap for me to pull in while solving a kind of physics problem about the occluded view to the left of how fast cars might be coming and what I could see or not see. And let's see, here's another example. So this is a still image. What do you think is going on in this picture? Anybody? There's a red light, there's a police officer. So one of the things about computer vision, a lot of the work is analyzing static images. And now the research frontier is moving to dynamic video understanding. But in this image, this police officer is actually waving me through a red light. And so I don't know why the video is a bit jerky. But if anyone here is a programmer, how do you write the code that says always stop at red lights unless there's a man on the side of the road who's a police officer who's waving you to go through the red light? And in general, for a reality check, I think interacting with people out in the wild, pedestrians, crossing guards, traffic cops, other drivers, all those sort of nods and waves. John Markoff, I think, referred to it as the social ballet of driving. And in general, we have to face situations like this. So what do you see in this picture? So obviously, you can see the sun. You can see a green light there. There's also a police officer standing right in front of me who's directing traffic and waving pedestrians in front of me. And this happens pretty much the entire month of October during rush hour heading westbound on Beacon Street. This is at Coolidge Corner. And so I'm not aware of you can talk about polarization or different sort of, I'm not aware of a computer vision algorithm that can interact with the police officer under these conditions. And of course, there's weather, which not only affects the sensing range and the traction of a car, but the Waymo Google self-driving car, for example, uses very precise prior maps to define almost kind of like virtual rails that the car can drive along. And when you cover the road surface, you take away all the benefits coming from the high-definition maps. So turning robots loose in the wild is really hard, really challenging. Beyond driving, I feel there's some larger topics here. First of all, I feel like we need a bit more of a worker perspective to the conversation about work. 30 years ago, I was an intern in a General Motors factory for 2 summers when I was at college at Penn, and I had to work with the union employees in the paint shop and evaluate their suggestions for improving the line and all sorts of tricky maintenance things. And I think that the workers that I really have an appetite for knowledge and a desire to learn new things, and I think we need to bring that perspective in and think about the whole retraining. Maybe we can send factory workers on sabbaticals to sort of learn new skills and bring them back to the world. But another thing is I think the physical interaction piece has been missing from the conversation. Having robots manipulate objects, really, really hard problem still. We don't know what we don't know in terms of solving some of these difficult tasks. And just one other example, Jan LeCun gave an awesome talk about machine learning. This is an example, it's a few years old, this example from a sort of a standard algorithm from a couple years ago from a wonderful guy named Fisher Yu, who was at Intel. He's now at Berkeley. He's brilliant. This is semantic scene segmentation and implementation from a guy I work with at Toyota. But here, red means a pedestrian. And sorry, the video's a little choppy, but what you'll see in a second, what's amazing is the ability to detect cars and road surface, and a more modern algorithm would do even better. But just as an example, in the video, a truck drives across, and the algorithm classifies the person on the side of the truck as a person or / rider. And the precision moving, it classifies it as a fence. And if you kind of squint your eyes, you can see the sort of vertical structure of the letters. Now, this wasn't trained on text on the side of trucks. But an algorithm like this might get a very average precision score on a benchmark data set. But it's something else to sort of turn it loose in the world and encounter all the tricky situations that we encounter. So there's this sort of understanding when an algorithm is working and when it's not working that we still might be very far from for turning things loose and really generally in the world. So, thanks.
I think it's you. Yeah. Great. Well, I'm just going to play a little video showing some of what we're doing out in the real world. There's a lot of really exciting technology being developed at places like MIT. You can go ahead and roll video. And what we've been trying to do at Vecna over the past 20 years is actually take a lot of that and deploy it in the real world.
Organizations need to adapt.
So we're dealing with a lot of these problems that people are talking about in somewhat theoretical terms.
And finding and keeping reliable staff is a challenge in and of itself.
This is a pretty typical scenario you'd see that essentially is what moves everything through our economy. When something is built, how does it actually get to your doorstep eventually? And it goes through a lot of places like this. Very chaotic, very inefficient in many ways.
Solutions to keep up.
The worker that you saw there with the red top and the green or other way around pants, I want to talk about him a little bit.
2 decades of experience building some of the world's most cutting-edge robots, partnerships with world-class institutions, a commitment to strategic R&D, and currently supporting thousands of products in the field, Vecna Robotics offers a comprehensive, infrastructure-free, end-to-end material handling automation solution. Whether you're moving totes, bins, carts, cases, shelves, pallets, or heavy oversized objects, we have you covered. No tape, wires, or magnets, no fixed paths, and no facility changes needed. We can also automate existing material handling equipment, and whenever you'd like, simply flip a switch and you can revert back to manual control. Vecna's technology is the result of decades of research into safe, reliable, autonomous navigation and is specifically designed to operate directly in collaborative environments. Our robots can navigate around obstacles, reroute themselves, and are equipped with advanced safety features which allow them to work effortlessly and safely alongside your staff. Vecna also provides a truly end-to-end automation solution. With the ability to simulate and optimize all material flows in your facility, each deployment could be tailored specifically to your individual needs. With implementations lasting days, not weeks, you can scale incrementally rather than committing to an entire system up front. And utilizing IIoT technology, all of our platforms are remotely monitored and supported to keep our robots working hard for you, allowing you to focus on other top-line initiatives instead of having to walk halfway across your facility to push a button. Automation that adapts to you, not the other way around. That's how automation should be.
So the one point I want to make, and I think it's something that has been brought up here before, is that we don't know what we don't know, and until we get these systems out there in the real world, we're probably solving or attempting to solve the wrong problems. Had a really interesting interaction with one of the workers at this particular facility. I decided that I was going to go and participate in the training and implementation there. And we gathered a group of workers around, and first question, hand went up. His first question was, okay, so these robots are taking our jobs. When are we getting our pink slips? And one of the people from the company stepped up and said, hey, I want you all to know that nobody here is going to be losing their job. You're going to have a job here as long as you would like, and do good work. But we have a real problem, and that is over 300% turnover. The point being that this is a job that's really not fun. People don't like doing this job, and their biggest problem was finding people to do that work and to keep them long enough to actually, learn the job and be efficient and that type of thing. But a really amazing transformation happened, and that was that exact same person, the moment we had them interact with the robot, physically touch the robot, the attitude changed, 100%, turned around. When he touched it, he touched that touch screen, he gave the robot a task. Suddenly, he stopped thinking about, is this robot could take my job? And he started thinking about, wow, my job's going to be a lot better now. And if I learn how to use this, maybe it can create career advancement for me, because then I can go and teach other people how to use this robot. So it's just a really fascinating social experiment in a sense of the fear of the unknown versus when I've physically interacted with it, suddenly it becomes a friend and a collaborator.
Tony.
Okay. I'm Antonio Torralba. I'm a professor in computer vision at CSAIL, and I wanted to talk a little bit about computer vision and some of the things that are happening right now and where we are and what we cannot do. And so it's a really exciting time for computer vision. Probably you have seen some of the demos today, and there are really amazing results out there. Things are working really, really well. But when you think of how we train our systems nowadays, what we do is we need to provide examples that will look like this one. Like you have to show a picture, you hand label some of the objects, people, cars, and so on, and you have to teach to the system everything about the picture. You have to tell that this is a street scene, there is a rainy day, there is a person carrying an umbrella here, there is another person walking here, and you have to provide a lot of data. And it's not just this picture. You have to give lots of examples like that, millions of examples like that. And the way in which we are doing this nowadays is by crowdsourcing. So you hire tens of thousands of people that will take images and hand label everything that is going on there. And then you will have a machine learning algorithm that will learn how to recognize all these things. The problem is that as you think of all the different tasks that you need to solve visually, this is a really complex thing. And there is a lot of knowledge. And you cannot think that you are going to be able to hand label everything, all the possible questions and answers that you have about the real world. You cannot just hand label everything. And just to show you how much power there is on your head and how much knowledge there is on your head in order to solve the vision problem, let me show you a video. It's a very low resolution video. Here it is. And probably you can see everything that is going on here. It's extremely low resolution. So most of the objects are only worth 1 pixel. And still, you can recognize what is happening here. You see someone working at the computer, listening music, and so on. And we have no computer vision systems that can solve this problem with such a poor input. And the reason why you are able to solve this is because you have a lot of knowledge, common sense knowledge about the fact that people generally listen to music and they use headphones, and you have all this knowledge that is very hard to hand label. And in fact, when you're watching this movie, you are putting into the interpretation all that knowledge. You're putting into it a lot more than what is actually present in the video. And to illustrate that, let me show you the original video in high resolution. Here it is. So you can see that not everything was what you suppose. He's really talking with the shoe. And he's not listening to music, but he likes to drink beer. That's not a mouse, it's just a staple. So you're just you just made up what you saw. There wasn't really all those objects weren't there. But you know what things are supposed to be in the world. So we don't have computer vision systems that can solve this, but you can. And the way that you have learned to recognize all these objects has not been because someone hand-labeled absolutely everything that you saw when you were 0 years old up to 3 years old. You had no parent labeling absolutely everything that you got to see. So how do the kids learn? Well, generally, they are going to be alone most of the time. They are just playing with the world. So here is a kid, and let's see how he learns to see and to perceive the world. You touch things. You play with them, you hear the noise that they make, how they feel, and you put it in the mouth to get that final bit of information that you need to recognize everything. That's what makes sense of the object. So most of the time, the kid is alone and is learning with these interactions with the world, and we have no computer vision system or AI systems that have this interaction across multiple modalities. People are working on this. In our group, we are also working on this, but this is still part of what is the current bottleneck in training machine systems. So here is another video of another kid. And so here there is no parent, but you can also have a parent involved in teaching the kid. So here is a parent teaching the kid. And how do you learn? Well, let's watch the video.
In the summer, I like to lie in the sun and watch the birds. And I like to watch the frogs in the pond. Then I curl up in my hollow tree and dream about spring. The end.
So just like machines, kids also want data. And they don't like it when you stop giving data. But this is a crazy environment in which you have the parent talking this language that the kid has no way of knowing, because this is the first time it's hearing this strange language. And it's also trying to make sense of the visual world, which also doesn't make any sense because that's the first time it's getting all those visual inputs. And you have to co-learn these two things that don't make sense by their own. And that's a task that current systems have a lot of problems having to deal with. And so we have to teach these systems in this artificial setting in which you label everything. But I think that if we want to solve really all the different problems in AI and build general AI systems, we need to start thinking about more human type of learning. Probably Jan has been talking about that in this morning, and there is a number of people thinking about these problems. So that's all I wanted to say.
Thank you. So, Cynthia, first, congratulations on getting Jibo to market.
Okay.
I was trying to remember how long ago it was that we met in San Francisco.
Like 2014.
2014, so it was
Very
3 years
beginning,
ago.
yeah,
I was
very
still
beginning.
working for the New York Times, so it was a
That's
long
right.
time ago.
That's right.
So what, about your journey, what have you learned from, what didn't you know at that time that you've learned since?
Yeah, so I mean, I think anyone from academia who tells you they're doing a startup, the first thing they tell you is doing research is fundamentally different than trying to actually get a product to market. And that's absolutely true. It's truly a Herculean effort to create something that you can actually mass produce, to create all the software systems that can be, run the data analytics and do the machine learning and just bring all of these techniques together, but also to coordinate all of the people, right? All the different peoples with all the skill sets. I think in terms of, on the topic of breakthroughs, I've been spending 20 years in this area of social robotics, and I think the thing that I've been finding, again, very reaffirming is all the things that I've been studying, discovering as a professor. There are literally thousands of Jibos now living with people, and we interview them, we get data from them and so forth, and they post on social media, and many of the things that I believed were the opportunities for social robots as a kind of unique experience for technology in the home are being reinforced by what we're hearing. So people, for instance, who many of them already have a Alexa or whatnot, and they say this is a fundamentally different experience. This is not about a digital assistant device. This is something that's more like a helpful companion that feels much more like part of the family than part of the stuff. And again, it just speaks to this profound kind of social and emotional species we are. And a lot of my research, whether it's in early childhood learning or pediatrics or elders or whatnot, is that the way that we as human beings make decisions and learn and interact, it's profoundly social, emotional, it has physical components, and of course it's cognitive. The more that you can support people in all of those dimensions holistically, the more we as human beings can invest in those interactions. And I truly believe the more it unlocks our potential, because we find again and again the more successful people are. And we do randomized controlled trials trying to understand what is it about a physical robot versus a virtual agent? What is it about the emotional expression versus just the information? And we see boosts in human performance when we layer these humanistic attributes onto these technologies, because we have evolved to interact and learn in the social world with others. I think what we're also finding is it doesn't have to be exactly human. And I think this is such an important point because people keep assuming it has to be exactly human to be the most effective. There's actually a lot of power and opportunity in have it not be human. There's a different kind of relationship. There's a different kind of interaction that's supported that can be very meaningful and beneficial for people. So that, I think, is continuing to be a story that I think we need to help people understand more. But it is a constant process of creating the technologies, deploying them, studying them, taking the lessons, iterating in order to kind of build this knowledge.
But you've kept your original target of a broad sort of home companion, not trying to focus it in a particular demographic or, okay.
That's right, yeah, that's right. And we really wanted to focus on all family, yeah.
So, John, in addition to being at MIT, you're at Toyota, and there's been so much discussion of complete self-driving here, but I wanted to ask a little bit about what might come before that, since now we seem to push the barrier out a little bit at this conversation, in this conversation. So what are the kinds of things you might wrap around a human driver near term to make us safer drivers?
Well, there are these two paths that sort of Google just, Waymo gave reporters rides in a car with no one in the driver's seat on Monday, and that's in sort of a mobility as a service level 4 kind of application. Think sort of Uber with robotic cars. But there's another path more to the privately owned vehicle market and how you would augment human drivers. And then I think that, as you've written, the handoff problem is critical. Can you trust the human to take the handoff? And we're working on a technology, we call it the guardian sort of approach, or a parallel autonomy, where the autonomy would be there running in the background and would sort of jump in for better safety. And so it's really hard to predict. I call it the space race of the 21st century. The level of investment in self-driving is just stunning. And I could argue all these different paths where things might go forward, and we really just won't know. We have to just see how things play out.
Are there specific features that you see the industry's already identified? You know, we've had everything from seat belts to radar to various braking systems. Are there next generation systems that are close?
Well, I know, like, for example, Toyota's publicly said it's put adaptive cruise control with emergency braking in nearly all of its fleet, and it's great to see the democratization of active safety. And but to get the big leap, I think, for example, the aging population is probably one of the biggest drivers. It was mentioned this morning, not just for cars, but also for mobility in the home and so forth. I think the demographics of more older drivers, if we can bring all the tools in the robotic and AI toolbox to make cars much, much safer, for example, for older drivers or teenage drivers, I think that could be a big win in the near term.
Okay. Daniel, I wanted to so first of all, are you guys trying, you're moving cases around and things like that. Are you moving pieces around too in the factories? Is it piece pick as well as case pick that you're trying to solve, the individual?
Yeah, as a matter of fact, it's interesting that early on, one of the big reasons that many were saying they weren't adopting automation in the warehouse factory manufacturing floor was because there was not a comprehensive end-to-end solution. And they were not interested in maybe stovepipe, you know, trying to solve this piece and then dealing with all the integration issues. So we actually decided early on that we were not going to go to market until we had a comprehensive end-to-end solution that could handle all of those different pieces at an appropriate level. And I'd caveat that with saying that the best way to be successful is to cheat a lot. And by cheating, I mean, you know, simplifying the problem, solving the right problems, choosing the right problems in the first place. But yeah, so we're one of the only ones out there actually that can move, you know, basically things from large, you know, multi-thousand kilogram loads all the way down to an individual item and do it all in an integrated end-to-end fashion.
So this end-to-end notion, does this, watching your, I guess they're not competitors, maybe we're a customer, but why do you think, or is there some unknown reason why Amazon bought Whole Foods? Is this actually about a warehouse close to customers, perhaps, instead of the food business?
Well, you know, it's interesting. I think that Amazon has a long history of investing early in things before it's really understood how it's going to pay off. Certainly, the food market is one of the largest markets in the world. Ultimately, we all buy food every single day, or at least consume it. So I think it's just an acknowledgement that that is a huge part of the economy, and they want to own that, and this is a step in that direction. How you handle food obviously has a lot of unique challenges too when you talk about automation.
Is a company like Symbotics a competitor of yours, or are they? How does it work in that you're interested? Symbotics is, I've been in a warehouse where there was an old style warehouse that had forklifts and other devices being run by humans, and then they had this thing that looked like a giant pachinko machine.
Yep. Yeah, we call those ASRSs, Automated Storage and Retrieval Systems. And I don't view them as a competitor. They're probably more of a collaborator than anything. There's not a one-size-fits-all. Sometimes conveyor belts or ASRSs and those type of fixed infrastructure approaches make a lot of sense. But what we're seeing is a trend towards flexibility. What people want is to be able to scale up and down very quickly. They want to be able to change routing. You know, once you install a conveyor system, $1,000 per meter on average, it's this thing, and it's there, and it's in your way. And when something's not going down it, it's still there and in your way. Whereas with our small RC20 robots, you can essentially create a virtual conveyor belt like that. It shows up when you need it. You unload the truck onto these robots. They take the stuff wherever it needs to go, and then they evaporate. They're gone. They're not blocking your path, and they're off doing something else that's useful rather than sitting there and waiting.
To the job question, I mean, you talked about sort of basically upskilling a human worker, but I mean, you have a sort of a more of a long-term, big picture look at the warehouse industry. Are we in the situation like was described earlier with this kind of interim job where the job might be around for a while as this relatively quick wave of technology pushes people out to lights out warehouses?
Yeah, I'm not a big believer in lights out warehouses. I really think that the idea of humans and robots working together is probably the optimal solution in many cases. There are going to be pieces that robots are going to be better at doing, but it's really going to be a collaboration going forward. And I want to just echo something Manuela said earlier, and Daniela Rus and I have had this conversation as well. The biggest obstacle to adoption of technology is just we've got to start adopting it, because we're not going to learn until we start having it in our everyday lives. And that's actually, we're in a great cycle right now where we're starting to see manufacturers, shippers, retailers starting to realize that if they don't start adopting automation now, they're going to lose. They're going to be so far behind, they're not going to catch up. Is there always a perfect ROI for everything? No, not yet. For the products we're deploying today, there's very clear ROI, but there's some longer-term investments that need to make. You mentioned manipulation. Huge unsolved problem. And it's particularly interesting to understand that oftentimes we're judging a robot. For instance, if I was going to compete against a robot for picking up that mug, you know, I'm going to win. I'm probably going to win almost every time. However, you know, if I'm just picking up one mug, you can start to see a scenario where, well, the robot can do it without bathroom breaks, and the robot can do it, you know, 24/7. But as soon as you say pick up 4 mugs, I'm going to win for decades. Well, you know, decade at least, maybe decades. And it's important to keep those factors in mind.
So they're keeping us on a shorter leash, I realize. But one last question, because both John and Antonio have shown us the challenges of everyday vision kinds of problems. Does this mean that it is going to be necessary to put LiDAR into self-driving cars? I mean, are we going to have to get around the vision problem to do something as challenging as a self-driving car?
Well, so first I will say that LiDAR is not different than vision. It's another visual sensing mechanism. So it's not that different. It's not that different. So you still have the same perceptual problems. You perceive a depth map with LiDAR, but still you need to recognize objects. You need to separate different things that might be connected, but they are actually 2 different objects. You still have to deal with occlusions. So it's the exact same thing. So it hasn't really made the problem much easier. There are a number of things that are easier. You can say something about distance. That became easier. But recognizing objects is just almost as hard.
Okay. I have a million more questions which I can't ask, but thank you very much. Thank you.